Hi and welcome to a brand new series of Build Your Own Architecture. Today we're focusing on video streaming, or video on demand as the industry calls it. Pete, what do we got in our 6 episodes?
So we've got 6 Amazonians coming along to actually talk to us about how to go about building your own virtual TV network online, Sean.
Nice. And we've got everything from recommendations to search to machine learning, where we're actually pulling out people's faces in live video. It's going to be a great series.
And we're going to use AI to figure out what's actually going on behind the click streams that our users are actually engaging in while watching our streams.
Nice. So join us for 6 episodes where you'll build out an entire video on demand platform.
This is Build Your Own Architecture, and we're talking about video on demand. Hi everyone, and welcome to the AWS series on Build Your Own Architecture. This is episode 1 on building your own video on demand ingestion. With me today, I have Girish. Welcome.
Hi, Dr. Pete. Thanks for having me.
And what do you do in professional services?
So I'm part of AWS Professional Services, and my role as a migration success consultant is to help our customers migrate their data and servers to AWS.
Awesome. So today we're talking about building a video on demand platform. And one of the most important things is to get started the right way. And we often talk about doing it the right way via a landing zone. So tell us what quickly is a landing zone?
Sure. So an AWS landing zone is a pre-configured AWS environment that's been built based on best practices. AWS provides our landing zones very easily for customers to consume using AWS Quick Starts as a method of very easily deploying landing zones directly, in a matter of minutes, directly through CloudFormation templates available on our website.
Whenever I think of a landing zone, I think of a very small little airplane strip where little planes come and land, and you want to evolve that into like a very large airport. And I always think of our customers as starting off small, but then going huge and building very, very large sort of, airstrips and so forth. So we're talking about building a video on demand platform today. Can you talk to us perhaps about what are some of the best practices about establishing a landing zone that's going to help organizations and customers building video on demand platforms? How do we get started?
Yeah, sure.
What's the journey look like?
Yeah, absolutely. So at AWS, we believe that security is job zero. And so we've got an icon up there for IAM, which stands for Identity and Access Management. What IAM does is it provides the guardrails to ensure that your AWS environment, including all services and data, is absolutely secure from day dot. And we ensure that that's the case, and it continues that way as you start growing and scaling your environment.
So it's a fine-grained controls to ensure only the right people have access to the right bits of data and systems.
Absolutely.
Okay, so let's just start a journey over here. So if I'm an organization who's just getting started in moving and building a video on demand platform, and I may have already built something on premises in my own corporate data center, can you maybe walk us through the kind of things we need to do after we've been set up securely to perhaps move my media assets, my metadata, content catalogs into AWS?
Sure, absolutely. So there are a couple of different methods that we'll be walking through as part of this architecture. The very simplest or easiest way to start migrating your data would be to do it over the internet. Now, while that is the easiest way forward, it's not a scalable solution to migrate your data over.
So which way is that? So that's over through up here?
Yeah, so that's through the internet and then over, if you'd like, to the AWS environment. Now, that can be done either directly through the AWS console or through the AWS CLI. Saying that, though, if you've got large amounts of data, it's probably not going to be the most effective solution of migrating your data over. What we'd recommend as part of this diagram here, or this architecture here, is using S3 transfer acceleration as a method to speed up that process and securely transfer your data into an S3 bucket.
So what does that actually mean? So moving your data from your on-premises into S3, our simple storage service, how does the S3 acceleration actually help me?
Sure.
What are the benefits?
So the S3 transfer acceleration leverages our AWS CloudFront content distribution network. And so what actually happens is, rather than going directly over the internet to an S3 bucket, you'd actually use AWS transfer acceleration with our CloudFront backend or CDN network to accelerate the transfer between the CDN network directly to the S3 bucket.
Okay, so go to the closest point of presence for us, which we have over 100 worldwide, and then we use our backend network to deliver that a lot quicker.
Absolutely, yeah.
Perfect. Is that secure?
Yes, absolutely. So the data is completely secure from the time it leaves your data center all the way into the S3 bucket itself. And we just leverage the AWS backend to accelerate that transfer between the point of presence to the S3 bucket itself. And this can drastically improve or decrease the time it takes to migrate your data from on-prem to S3 using transfer acceleration by up to 400%. So it's up to 400% quicker by using S3 transfer acceleration.
That's awesome. However, so if I'm just getting started and I've got a very small media footprint, that's probably okay for me.
Absolutely.
But what if I've been in the business for a little while and I might have a lot of digital assets that I want to move into my video on demand platform in AWS? What are my other options? Because obviously that has, the public internet, it may not be always available. There's multiple hops, lots of latency. What are my other options, if any?
Well, I would recommend that you go down the path of AWS Direct Connect.
And what's that?
So AWS Direct Connect is a private physical connection that connects your on-prem network or corporate data center to the AWS environment. So this is a private connection that you can get configured through your favorite telco provider.
Right.
Very similar to how cross connects have already been incorporated to a lot of small to medium to large organizations as well. This gives you a private connection between your on-prem data center and AWS.
Because it's my own private link via my telco of choice. And how fast is this compared to going through the public internet?
Because this is your own private connection, you can get 1 gigabits per second or even up to 10 gigabits per second connections between your on-prem and AWS environment. You can also get up to 4 ports configured. And the good thing about Direct Connect as well is that with a feature called link aggregation groups, you can group up to 4 different links to give you, theoretically, 4 times the throughput when you've connected that environment.
So that's 40 gigabits from what I'm hearing.
Absolutely, yeah.
Okay, so that'll buy me a lot of bandwidth to move my data over. Okay, and so while I've got this connection, private link, obviously it's lower latency, it's more of a point-to-point setup. Walk me through how I would perhaps move my assets, my media, through maybe file servers into, or do I go straight into S3? What are my options?
Well, yeah, what we've got here is, so you absolutely can move it directly to S3. Saying that, though, what you'd probably want to use, if you currently have all your assets and your media on existing file servers, AWS have a feature called AWS Storage Gateway, which is a virtual appliance that you install on your on-prem environment. And it provides a NFS share, if you like, which is a network file system share directly as a mount point to your file servers, but it utilizes S3 storage as the backend to that. So technically, you can move, or it'll present a file share or mount point to your file servers when it actually is S3 in the backend. So you can very easily actually move data through Storage Gateway directly to S3.
Okay, so basically I make S3 look like an NFS mount point, and whatever I copy over actually ends up in here?
Yes, yes it does, yeah. And you can actually access that data directly through S3 as well. And the good thing about using this in a hybrid mode, if you like, is if you still need to access the data on-prem, Storage Gateway gives you access to that data on-prem while it still sits in S3. And we can also, with Storage Gateway, you can cache your most recently used data on-prem as well. So it gives you very fast access to your data while it still sits on-prem before it moves to S3.
Okay, so Girish, if I actually have my original raw file, my mezzanine file formats, what could I do with them? Because they're very large and not frequently accessed.
Yeah. So I'd recommend that you could either use S3 to store your data, where we can migrate them directly to S3 using Storage Gateway. Another option is to archive your data using Glacier, which is another service. It's got the same durability as S3 at a significantly cheaper price, which we would typically use for archiving and backing up your data. Very similar to what you'd use to back up tapes in your existing environment. Now with Glacier as well, and with Storage Gateway, you also have the feature of a virtual tape library. So speaking about backups, you can actually present a virtual tape library using Storage Gateway to your file servers and actually back up directly to a virtual tape library that has S3, and you can lifecycle that to Glacier for archive.
So instead of tapes, you go straight into the cloud.
Yep.
Wonderful. All right, now what if I've got a bigger problem? What if I've been in business for maybe a few decades and transference may not be sufficient for me? What other options have we got for those media organizations trying to move even larger volumes of media assets into the cloud?
So when we start talking about terabytes or even petabyte storage, that's when we look at a Snowball appliance, which is a physical appliance that we actually get shipped to the customer's data center or customer's site. They then plug that device directly into their network to start ingesting data, and then that Snowball appliance is then shipped back to us, and we then ingest that data into S3. So the good thing about this particular option is that, as you see, it completely bypasses the internet. So you can actually get faster transfer speeds than running it either through Direct Connect or even over the internet itself, just because it can handle a large amount of data, and depending on what your speeds are, you can actually move it a lot quicker than running it through the internet.
Gotcha.
It's extremely secure.
That's my next question. Is it secure? Yeah, if it's being shipped by your favorite courier service, what do we do with the data on the devices that are actually being physically shipped from our corporate data center into AWS?
Yeah, so we utilize AWS Key Management Service, and the keys to encrypt, and all this data is encrypted, and the keys that are used to encrypt that data is managed by our customers. So no one will be able to decrypt that data or use that data for anything apart from the customer themselves. The good thing about the Snowball appliance as well is that it's physically durable, and it can handle large amounts of G-forces, and it is a pretty beefy.
So being shipped in the post. Yeah. Got it. All right. So as we ingest in this stuff, where do we keep the metadata for this? Where do we store that?
Yeah, good question. So we've got DynamoDB, which is a managed service by AWS. It's a high performance, low latency, NoSQL database that's used to actually manage the metadata and store the catalog of the information that we're starting to migrate into S3.
Okay, so my bits are in the cloud. I've also got some metadata knowing what the file names are and so on and so forth. But if that was not enough, and I've got even more media assets, okay, what's the final option of getting zettabytes of information into AWS, especially from a media perspective?
Yeah, so if you've got extremely large amounts of media, then I would recommend we go down the path of using Snowmobile. Okay. So Snowmobile, as that icon shows us here, is a truck. Yeah, it's pretty much a truck with a container, and it's got large amounts of zettabytes, so if you like, exabyte scale storage. And we use this for customers who've got extremely large amounts of data. Again, similar to Snowball, I think this is the next level up. It does come with a few additional security features. It's got GPS tracking. It's got its own security team who are physically there, 24-hour video surveillance as well. So it's got a little bit more security on that as well from a physical perspective, but it still leverages the same KMS services as we would with Snowball and some of our other services as well.
Girish, thank you so much for showing us how to ingest vast amount of data via the online means as well as offline. Thank you for watching episode 1 of Build Your Own Video on Demand platform. And in episode 2, we're going to be talking about transcoding. So stay tuned.
Hi, and welcome to episode 2 of Build Your Own Video on Demand platform. Today we're talking about transcoding. I'm Sean Ray from AWS, and with me,
Jared Speaker, a solutions architect from Amazon Web Services in Sydney.
Okay, and so what we discussed in episode 1 was really ingesting the content and getting it into S3, and we're going to go on from there in episode 2. So Jared, we have a architecture on the board here. Can you talk through the transcoding workflow?
Yeah, certainly. So the previous video finished up with assets being imported into an S3 bucket here. We can use S3 events to be able to kick off additional workflow to be able to process those assets. So the first thing we actually have here is an initial Lambda function that will start looking at those assets. We'll run media info, we'll verify that we can actually read those assets, and we can then start populating a DynamoDB table with metadata related to those assets.
Okay, and I notice in your Lambda you have it in a box here. Can you explain why it's in a box?
It's in a box because we use this icon just to represent a single Lambda function. What we could actually have is many Lambda functions within this. And so this is essentially within a box representing a step function. Now, step functions allows us to define workflows to call different functions and different processing paths for the overall workflow that we're going to achieve here. So additionally, with not just the media info step of that Lambda function, we would also have a separate Lambda function in there also to kick off the next step function that we use to actually then start processing and transcoding our assets.
Okay, and do you see this as one kind of step function that goes through the entire pipeline, or is it multiple step functions getting invoked at different points?
Well, this type of architecture is actually based off one of our reference architectures. We have a VOD platform workflow architecture that's available on the AWS Answers website. This reference architecture actually calls these out into 3 separate step functions. We essentially have one step function to look for after the preparation of the data and populating our initial metadata into a DynamoDB table. We also have a second step function here to look after the actual processing, and then we have a final step function down the bottom here to look after post-processing and verification that the transcode process is completed successfully.
Okay, and I guess one of the hot topics in media is really around media asset management, and how do you manage all of those assets? You get different data in, you might get some small bit of metadata with the files as they get uploaded from the content providers. How are we kind of solving that problem here?
So DynamoDB really acts as that central metadata repository for what we use. The solutions that we typically see with media customers, those large media asset management or MAM solutions, will typically involve S3, DynamoDB together to be able to not only have that large store of video assets, but then the metadata is stored in a table as such, or a database, to be able to perform easy lookups and to be able to obtain that information really quickly and easily, not just from within transcoding solutions, but other aspects of the overall workflow, including eventually client lookups. There's no reason why you can use the media asset management solution as a central point to be able to enable or disable content to allow users to see what content is available for them to view.
So we have our metadata in Dynamo in our MAM. We have ingested the data into S3. When do we decide that we want to actually transcode something, and what do we transcode it to?
So a lot of the time, organizations will have a predefined process. They'll have a predefined workflow and standard output formats that they'll want to transcode into. So in many cases, as soon as an asset lands in S3, we can start doing some transcode operations on that. If you do require additional processes outside the workflow, then that can be a manual action. But you want to try and minimize the amount of manual actions that you have throughout this and use a workflow such as this. If you've got many thousands of pieces of content, you don't want to be there sitting there and doing a manual process for each one of those content pieces. So having this initial step where we do the preparation, we validate, we ensure that the content is valid and supports the appropriate formats, is not corrupt, and so forth. Once we're past this preparation stage, we can then kick off this second step. Now, we have an initial Lambda function here to actually communicate with the Media Convert service, and that is the service that's going to be performing our transcoding actions. The Lambda function here can actually make decisions based on some of the metadata information that's been provided to it, but it can also just, if it's missing that data, it can follow a default workflow. And so one of those decisions that it couldn't potentially make is with regards to priority. So let's run the scenario where you've got urgent news content that needs to be transcoded at a higher priority than the rest. We can make that decision with this Lambda function and then use multiple transcoding queues within Media Convert to essentially create a higher priority queue and then put that news content to that high priority queue, get it transcoded with much higher priority than the rest of the baseline content that we're working with.
And I guess to take that one step further, there's not also just always immediate content. There might be, times where, say, you sign a new content agreement. Now you're taking on a movie catalogue of thousands of movies or thousands of TV shows. You don't necessarily want to transcode all that at the most expensive time. Is there methodologies where we can schedule this maybe to be cheaper?
There are certainly ways that we can do this. Again, it really comes down to populating that metadata appropriately. Now, if we're just importing objects at bulk, we might not be populating that metadata, but this is where an overall MAM solution will typically provide advantages for broadcasters. Even if you're not using a MAM solution, you can typically build out your DynamoDB tables to be able to factor in that as a piece of metadata that you would like to include with that, and we can use Lambda to make those decisions on when to kick off that processing. Also, that functionality within the step function, we can have specific wait states configured in the step function. So if something is really low priority and we only want to process it when cost is cheap, then we can push that particular workflow through that step function to be in a wait state until that price becomes more palatable or more desirable for that transcoding process.
Okay, I guess one of the other things that gets talked about is the fact that we have iOS and Android and smart TVs and all these different devices. We also have lots of different bit rates now, right up to 4K. How are we deciding kind of what to convert those into, and where does Media Convert, I guess, what does it provide in that regard?
So Media Convert provides full adaptive bitrate support and will transcode into various different formats, all of which are, or most of which are supported on mobile devices, but then there are other formats that are supported on desktop devices and so forth. So ultimately the end output from Media Convert gets pushed into an output S3 bucket here, and that could be one long form MPEG-4 video, or it could also be various different adaptive bitrate formats that you want. So if you're delivering to an iOS device, we can ensure that we've got the full HLS profile and playlist and manifest file to be able to actually go out with that content, as well as each individual video segment that can be then consumed by the device.
I also noticed that you've got notifications out here, our simple notification service. What are you using notifications for in this workflow?
So the big question is, what happens when things go wrong? Because things inevitably do go wrong. We architect for failure. And so SNS is an integral part of the solution to be able to notify end users when something does go wrong. So here at this preparation step, let's say our video is corrupt. We don't want it to just push it through the workflow blindly, because we're going to get all sorts of flow-on failures. So if we actually have at this stage a push out to SNS to notify end users and manual staff to actually look into the problem at that stage, we don't have to waste effort down here. Similarly, if a media transcode job fails, we can then also push a notification to Simple Notification Service and actually push out that notification to everyone else. Likewise, I haven't talked about this step yet, but when we do validate that the transcodes have been completed, if something goes wrong or if there's a problem with the output transcodes, Simple Notification is our friend to be able to let us know that something's gone wrong.
So, in media, we need to support a lot of different devices, iOS, Android, things like set-top boxes, smart TVs. We also need to think about adaptive bitrate. Not everyone has the same type of internet connection. How are we, catering for that in this architecture?
So a lot of that is typically standardized by a lot of VOD providers. You'll typically find that all media assets will be transcoded with the same profile, the same bit rates, the same level of device support. And that can all be set up within the Media Convert service. You can define the profiles that we will standardize on, and then it's just a matter of this Lambda function transcoding with the right profiles. If there's some customization that needs to be done along the way, then we can leverage the metadata system within DynamoDB to actually inform Lambda, so we can make informed decisions on what profiles should be used for those edge cases. But for the most part, the idea and the intent is to standardize on that, especially if you've got many thousands of pieces of content coming in regularly.
Okay. And then one of the other parts we haven't really talked about, I guess, is this infrastructure. What's happening down here with CloudWatch and Lambda?
So every single job that Media Convert does is actually looked at and monitored by CloudWatch. And specifically, what we want to be able to do is determine whether a job is successful or if it has a problem. Now, we talked about earlier, we've got Simple Notification Service here when there's a job that's failed. So it means that we don't actually have to have some other agent sitting off to the side regularly polling the service saying, are you done yet? Are you done yet? Are you done yet? Sounds like my children, actually, constantly going back and forth, are we there yet? And so importantly, when we have this a successful transcode coming down from Media Convert and picked up by CloudWatch, it can invoke this Lambda function or this step function that runs a number of different Lambda functions. Now, one of these Lambda functions would be able to do a media info to validate our content to ensure that the transcode was successful. We want to ensure that, say, it's HLS format and we've got an appropriate 2 megabits version of it. Is it at the right aspect ratio? Is it at the right resolution? Is it at the right bit rate? And so forth. We can take some of that metadata information and push that into our DynamoDB table as our central metadata store. The idea here is that we've got our content and we've got a list of all the adaptive bit rates and all the different formats that we've transcoded to, all residing in the one table, which can be used by end user devices. End user devices can essentially pull that down and read that content, determine what exact file that they actually want to pull down and actually play back. And then those devices can then read that content directly from our output bucket in S3 and then start playing that content back.
Okay, so we've got our content, we have it transcoded, we've done a double check, so we're running media info to make sure that we've actually transcoded it in the right way. We've updated our metadata table so that users now know that that's available in particular bit rates. And so finally, I guess, in episode 3, we're going to talk about playback. How does this fit into playback and where are those final assets stored?
So the final assets are still stored over here in S3. We want to keep them separate from the assets that we store here. Importantly, Media Convert can also apply DRM features to that content as well to secure it and lock it down. But I believe we'll talk about some of the other ways that we can secure that content. Essentially, DynamoDB, though, becomes our central point of metadata, and this database essentially provides the client and the end users what content that they have access to and where they can actually retrieve that content from.
Thank you for coming in today, Jared. That was episode 2, transcoding, and in episode 3, we will look at playback.